All right, class, let's say you have a glass of water, okay, and you add a piece of solid to this glass of water. What are the possibilities? If you take a piece of solid and you add it to water, what are the two possibilities? Don't overthink it. Here are the two possibilities. The solid could dissolve and be soluble, or the solid could not dissolve and be insoluble. Okay, so it would either dissolve, it would either, if you add the solid to this, it will either dissolve and be soluble, or not dissolve and be insoluble. Now, if it's soluble, when you add it, when it dissolves, what was that? What happens is you form a clear solution. Okay, so when the solid dissolves, what happens is you form a clear solution. Now, clear does not mean colorless. It could have color, but it could be clear. So if solid dissolves in water, it would be soluble and it will form a clear solution. And what we call that solution, we call it aqueous. AQ for aqueous. And what aqueous means dissolved in water. So it would dissolve in water and have a clear solution, and we call it aqueous. Aqueous means dissolved in water. So far, so good? Okay. Now, what we're going to talk about, we are going to talk about solutions right now. And remember, what's the solution again? We just talked about it. Solution is when you have solid and the solid is dissolved in water. So when solid is dissolved in water, what you have a solution. You have an aqueous solution, right? You have an aqueous solution. Okay. Now, what we're going to talk about today is that when you have a solution, again, what does it mean to have a solution? Solid dissolved in water. Solid dissolved in water, we have a solution. Now, when we have a solution, now here's the idea. Would the solution conduct electricity? Would the solution conduct electricity? And that's what we are going to talk about. And if, let me actually draw something for you first. If we were in lab, this is a common lab that we would do. So here is, I have my solution in here. That's my water, that's my solution in there. And then, this is a little hard to draw, but I think I got it. Let me see. Whoa. It's a little bit harder to draw on this. There we go. Okay, what is this? Can you guys guess what this is? Yes, that's a light bulb. I'm sure that's exactly what you thought. When I was teaching this class in person, everyone was like, oh, that's an alien. It's like, no, it's not an alien. It's a light bulb. So here I have a light bulb. Okay, go with it. My drawings are not the best, I know. Now, I have a solution over here. Some kind of solid dissolved in water. A solution sometimes can conduct electricity. And if a solution conducts electricity, it's going to turn on the light bulb. Now, solution will conduct electricity if it has free ions. So, if it has free ions, then what's going to happen is going to conduct electricity. You guys are okay with this so far? Okay, let's just summarize what we talked about. So when you add a solid to water, you could either be insoluble, doesn't dissolve, or it could dissolve and be soluble. When it's soluble, it dissolves, you have a clear solution. We call that aqueous. Aqueous means it's dissolved in water. Now, solution. When you have a solution, what does it mean to have a solution? When solid is dissolved in water. Now, some solution, they can conduct electricity and they can turn on the light bulb. What type of solution can do that? The one that have free ions. And we're going to go over what that means to have free ions. Now, you've done this at home many times. You've probably taken NaCl, which is table salt, and you've added to water. Have you done that? If you haven't done that, you got to try it tonight. It's going to change your life. If you take salt which is sodium chloride, and you add it to water, the salt will disappear, the salt will dissolve in water, and what you end up having a clear solution. I actually want you to do that if you've never done this before. Take salt, dissolve it in water, you're going to have a clear solution, because solution is solid dissolved in water. Now the question is, this clear solution, will it conduct electricity? Will it turn on my light bulb? Basically, can you turn on a light bulb, electricity, with salt water? Let's find out. So when you have NaCl, when you have salt, when you add water to it, when you add water to NaCl, what happens is water breaks up NaCl. Water, it breaks up NaCl into Na plus and Cl minus. Okay, so water is going to break up NaCl, and then water is going to, and Na plus is going to be surrounded by water, and Cl minus is going to be surrounded by water. But water breaks them up. That's how they dissolve in water. So water breaks them up into their ions. Now, we call this aqueous solution because it's dissolved in water. So water breaks them up, and then it's going to dissolve in water. So water is going to surround Na plus and Cl minus. Now, Na plus and Cl minus, what these are free charged ions. So I had NaCl. Let's take a step back. And if you remember, NaCl is Na plus and Cl minus. When you add water to it, the water is going to break up these two ions. It's going to break them up, and then I'm going to have Na plus, and then I'm going to have Cl minus. And they're surrounded by water, and they're broken up. So far, so good? Okay. Now, when you have free charged ion, what that means is free charged ion, they can carry electricity. Because what is electricity? Electricity is nothing fancy but charges. Electricity are electrons, they're charges. Okay? So if I have free charge ion, they can just carry the electricity. So they are going to be conductive. So when I have charge ions, when I have free charge ions, like I do here, what they can do, they can just carry electricity, because what is electricity? Electricity is nothing fancy but charges. And these can just carry the charges. They can carry the charges. You guys are good so far? Okay. And again, what does AQ mean? It means dissolved in water. So, yes, with a salt water, you can turn on your light bulb. Isn't that crazy? With the salt water, yes, you can turn on the light bulb. All right. Now, let's talk about hydrochloric acid. We've talked about this before. HCl. Is that a strong acid or weak acid? Go back to that lecture. If you go back to that lecture, you are going to see that HCl was a strong acid. It was one of the few strong acids that we have. And we said, what does it mean to have a strong acid? If you remember, we said a strong acid, what they have 100% dissociation. Do you guys remember that? We said they ionize, they break up, 100% dissociation. That means if I have hydrochloric acid, every single hydrochloric acid in water is going to break up into H plus and Cl minus. It's going to break up into ions, 100%. Because the strong acid, that means it would completely dissociate. Now that this is dissociate, do you have free charge ions? You do. Because what are these? This is a charge ion. This is a charge ion. Remember what an ion is? An ion is what? It's something that has a charge, right? And then they are free because water is surrounding them. So what I have free charge ion. So what I have free charged ions. Because water broke them up. So I have free charged ions. So can HCl solution turn on the light bulb? Yes, it can. Yes, it can. So free charge ion, they can carry electricity and they can turn on the light bulb. Now, there is a fancy name for free charge ions. And that fancy name is electrolytes. Oh, where have you seen that word before? You've heard of that word before. In a commercial, probably. Gatorade. Right? If you ever watch a Gatorade commercial, it's like, oh, you gotta buy Gatorade, you're gonna have some of this Gatorade, because if you have our solution, what's gonna happen is gonna, they show the athlete, they have energy, they can run. Now, here's the thing. They use the fancy word electrolytes, but that's nothing fancy. It just means free charge ion. So you can go take some salt, dissolve it in water, and then you're going to have free charge ion, and you can tell people, oh, I have electrolytes right now. I'm drinking electrolytes, right? So if you add sugar, if you add salt to water, and then you can just tell people, my solution has electrolytes. It sounds better than free charge ions. So yeah, it's a good advertising strategy. It's like, oh, we have electrolytes, but it's nothing fancy. It's just free charge ions. It's just free charge ions. We're good so far. And free charge ions, they can carry electricity, because what is electricity? Electricity is nothing but electron. You guys are good so far? Okay. Very nice job. Now, the question is, actually, let me give you another practice problem. Let's say I have magnesium nitrate, and I'm going to add this solid to water. Okay, so this is a solid, and I'm going to add it to water. The question is, will this solution, if I add this to water, will it conduct electricity or not? Will it turn on the light bulb, or will it not turn on the light bulb? As it turns out, magnesium nitrate would dissolve in water. Okay, magnesium nitrate would dissolve in water. Now, what does that mean? Here's what it means. So I have magnesium, which is charge of +2, and each magnesium is going to have 2 nitrate attached to it. You following me so far, right? Because this is ionic compound. So if you add this to water, what's going to happen is water is going to break it up. Water is going to break up this magnesium nitrate. When water breaks up the magnesium nitrate, what I end up having, I'm going to end up having an Mg +2 and 2 NO3 minus. Now look over here. So if this breaks up, I'm going to end up having 1 Mg +2 and 2 nitrate, right? So this is what water is doing. You're adding a solid to water. There's ionic forces, there's ionic charges. They're held together nicely. You add it to water. Water is going to break them up. When it breaks them up, now I have 1 Mg and 2 nitrate. Now, do you end up having free charge ions? Yeah, because what are these? These are free charged ions. They're free because water broke them up. Now there are ions because they have charges. So these are free charge ions. And if you have a free charge ions, what does that mean? It means it's going to turn on the light bulb. It's going to turn on the light bulb. You guys are good so far? Okay. Now, how did I know NaCl would dissolve in water and would turn on the light bulb? I mean, this is easy because you can actually try it out. You can go take salt, add it to water. It's like, oh, it does dissolve. So this is going to work out. I knew hydrochloric acid would dissolve in water because I know hydrochloric acid, it has 100% dissociation. How did I know magnesium nitride was going to dissolve in water and break up into ions? How did I know that? Okay, now you got to take out the handout that I gave you, the solubility rules. Take it out. Here's the solubility rules, okay? Now, if you want to know if something is going to be soluble in water or not soluble, I mean, you can always test it out, right? Go get some water, add the solid to it, see if it dissolve or not dissolve. But if you don't have the solid in front of you, then what you are going to do, you can look at the solubility rules and decide if this is going to be dissolved in water or not dissolved in water. And remember, when something is dissolved in water, what do we call it? We call it aqueous, right? So this would be an aqueous solution because this would dissolve in water. And the way it dissolves in water, water breaks up these two ions. All right, now let's read the solubility rules together. Do you have to memorize the solubility rule? No, I will give it to you. If a base or a salt, again, salt means ionic compound, is soluble based on the solubility rules below, it will dissociate and break into ions in water. Okay, so here is the solubility rule. It says basically the solubility rules is going to tell you if something is going to dissolve in water or not dissolve in water. So far, so good. Okay, now I want to make sure you really understand this before we move on. So I have a beaker with H2O in it. Now the question is, if I have a piece of solid and I add it to water, would it dissolve or not dissolve? How would you know if it would dissolve or not dissolve? You can actually test it out. You can go to lab, add this to water, and then wait to see if it would dissolve or not dissolve. Or if you don't want to go to lab to do that, you can look at the solubility rule. And solubility rules will tell you if something is going to be soluble in water or is it not going to be soluble in water. And if it's soluble in water, then what's going to happen is going to turn on the light bulb. Okay. Now, let's do this together. The first one is, I'm going to do a bunch of them, and we're going to go over it, and then you're going to decide if it's going to be soluble or not soluble in water. Let me write all this down. Okay. Are you ready? Now, so what's going to happen is I'm going to add all this. So these are all solid. I'm going to add them to water. The question is, are they going to dissolve or not dissolve? And if they dissolve, you're going to have a solution with electrolytes, fancy word for saying free ions. They're going to turn on the light bulb. Are you ready? Okay, let's do this. So lithium bromide, is that what's going to happen? What do you think? Here's how you would read the solubility rule. So lithium bromide, I have lithium and I had bromide. As long as you find the rules for one of them, then you're done, okay? Now, lithium is in group 1A, right? It says all 1A and ammonium are soluble. There are no exception. So every time you see a compound that has a 1A compound, a metal from an atom from group 1A, you go, oh, that is going to dissolve and is going to turn on the light bulb. Okay, that is going to dissolve and is going to turn on the light bulb. So lithium bromide, that would be soluble and there are no exception. So yes, this will dissolve. Now, I'm going to write this down. So this is going to dissolve. Now, when this is dissolving, again, remember, what happens is water is going to break them up, right? Water is going to break them up into ions. So I'm going to have Li plus and Br minus. Water breaks them up into ions. Water is going to break them up, and then you're going to have free charge ions so they can turn on the light bulb. They can carry the electricity. So far, so good? All right. Sodium sulfide, what do you think? Is that going to be dissolving in water or not dissolving? Is it soluble in water or not soluble? Well, sodium is also from group 1A, right? So this is really easy. Every time you see group 1A or ammonium is going to be soluble, there's going to be no exception. So yes, this one will also dissolve. Now, when it dissolves, again, water is going to break it up into ions, right? So water is going to break it up into sodium and into sulfite. But when water breaks this up, how many sodium do you have? You have 2 sodium. So it's going to break it up into 2 sodium and 1 sulfide. Now remember this example that we did. So like magnesium nitrate, you have magnesium, 2 nitrate attached. When everything breaks up, you have 1 magnesium and you have 2 nitrate. This is where those coefficients come from. So far so good? Okay. Now lead-2 iodide. Look at the solubility rule and tell me, is this going to dissolve or not dissolve? So lead-2 iodide. If you look over here, there is no rules for lead. But we have a rule for halogen. Chloride, bromide, and iodides. They are soluble except if it's next to copper 1, silver 1, gold 1, mercury 1, and Pb plus 2. So what the rule says is that halogens are soluble except if it is next to one of these. If it's next to one of these, then it's going to be insoluble. If it's next to one of these, it's going to be insoluble. Now over here, iodide is next to Pb. Is Pb one of them? Yeah, Pb is one of them. So again, chloride, bromide, iodide, if they're next to one of these guys, that's going to make it insoluble. So what that means is the PbI2 is going to be insoluble. It's going to be insoluble. So I'm going to put an S because it's not going to dissolve. I can't put an AQ because it's not going to dissolve. It's going to be insoluble. Again, because the rule says if one of these guys are next to the halogens, they're going to make it to be insoluble. So far so good? Okay. Now let's do more practice problem. Let's do potassium silicate. I'm going to add it to water. Magnesium chloride. I'm going to add it to water. Calcium phosphate. I'm going to add it to water. Okay. So let's do these ones first. So I'm going to add these to water. Now the question is, are they going to be soluble or not soluble? What's going to happen? Are they going to dissolve or not dissolve? So potassium silicate, what do you think? Hopefully when you see this, you go, hold on. Potassium is group 1A, right? You can find potassium group 1A. Every time you see group 1A, what are you going to say? Say, yo, group 1A, they're all soluble and there are no exception. Okay? So this is going to dissolve. Potassium silicate is going to dissolve. Again, when it dissolves, water is going to break it up, right? Water is going to break it up. What is water going to break it up into? It's going to break it up to potassium and it's going to break it up into silicate. -4. When it breaks it up, how many potassium do you have? You have 4 potassium. Again, it's going to break it up. You have 4 potassium and then you have a silicate there. So the water is going to break it up into ions. It's going to conduct electricity and is going to dissolve. Okay. Now I haven't been putting this on there, but you can write AQ for all of these because what does AQ mean? AQ means dissolve in water. AQ means dissolve in water. All right. MgCl2, what do you think? Is that going to dissolve in water or not dissolve in water? So if you look at it, I have no rule for Mg. But hey, every time you see halogens, we have rule for a halogen. Chloride, bromides, and iodides, they are soluble except next to one of these. Is Mg one of them? Mg is not one of these. So chloride is going to be soluble because Mg was not one of the ones that would make it to be insoluble. So it's going to dissolve. Again, when it dissolves for ionic compound, don't forget water is going to break it up. Water is going to break it up into ion. So I'm going to have Mg plus 2. And when it breaks it up, I'm going to have 2Cl minus, right? Because I have 2Cl minus over here. Some people might say, the last question, how come the silicates stay together? Because silicate is a polyatomic ion. So it's going to stay together, right? The polyatomic ion. You can't change the compound. All right, calcium phosphate. What do you think? Would that dissolve or not dissolve? There is no rule for calcium, but we have a rule for phosphate. So there's no rule for calcium, but here's a rule for phosphate. Ready? Carbonates, phosphates, silicates, sulfites, and chromates. They're insoluble except if it's next to 1A or ammonium. So these are all insoluble except next to 1A and ammonium. Is phosphate next to 1A ammonium? Nope, calcium is 2A. So what does that mean? That means this would not dissolve. This would not dissolve. This would not dissolve. It would stay together. So you cannot make an electrolyte from this. You guys are following me so far? Okay. Ready for next two? So far, really nice job. Next two, let's do sodium nitrate and nitrous acid. I'm going to add it to water. Would they dissolve or not dissolve in water? What's going to happen? All right, pause my video and then do this, and then we're going to go over it together. So, sodium nitrate. Hopefully, you're going to come over here and say, hey, I know sodium is 1A group, right? Sodium is 1A group. When you see 1A group and any of the atoms in the 1A group, don't even think about it. You go 1A group, that makes something to be soluble. So this is going to dissolve. And then you're going to tell yourself, when something dissolves, what that means is water is going to break up the ions. Water is going to break up into ions. So I'm going to have Na plus and NO3 minus, because this was again, all of these are ionic compound. When they break up into ions. So far, so good. Okay. And again, I've been really bad at this. So you can write an AQ for all of them because it means it dissolves in water. All right, next one. HNO2. Would that dissolve or not dissolve in water? So you might be tempted to go, oh, nitrite, nitrate, acetate, they're all soluble. There's no exception. But here is the tricky part. You ready? We're going to read this together. Solubility rules is for bases and ionic compound. Okay? Or salts and bases. Ionic compounds are the salts. So solubility rules is only for ionic compound and salts. And bases is not for acid. Is this an acid? Yeah, this is an acid. Do you agree? This is an acid. Can you name this acid for me? The name of this acid is nitrous acid. Nitrous acid is an acid. But you already know the rules for acid. Remember the weak acid and a strong acid? The weak acid would only partially break up and dissociate, but the strong acid would completely break up. Okay? Now, you have this from before. Before I go over this for this lecture, nitrous acid, weak acid or strong acid. Find your strong acid notes, the list that I gave you, and tell me, is it a strong acid or weak acid? This is weak acid. So, weak acid, right? And if you remember, we said weak acid, only a few of them would break up, but most of them are going to stay together, right? So what I want you to do for weak acid, I want you to keep them together for this class. I want you to keep them together. And the reason I want you to keep them together is because, yes, it's a weak acid. A few of them will break up into ions. A few of them will dissociate. But 95 to 99% of them is going to stay together. So we are going to keep it together. We're good? Okay. So you already knew this. You don't even need this. But let's go over this anyway. The solubility rules does not apply to acids. All acids are soluble, but only a strong acid would dissociate and break into ions in water. You knew that. The acid listed below are considered strong acid. Okay, you already had this. These are the strong acid. HCl, HBr, HI, H2SO4, HNO3, HClO4. Now, HNO2 is a weak acid. If you're a weak acid, you're going to keep it together because you only would partially dissociate. Most likely, most of it is going to stay together. So we're just going to make sure we make it stay together. Now, there was one more thing, and this is the last part about this. It says all acids are soluble, but the strong acid would dissociate. So, acid basically exists in water, right? Acid exists in water. That's the way I think about it. But the strong acid would completely break up, and the weak acid would only partially break up. But because all acids are soluble in water, I can still give it an AQ. Because what does AQ mean? AQ means dissolve in water. AQ means dissolved in water. You guys are good so far? Okay. Ready to do a couple more practice problems? Let's do it. Alright, here are more practice problems to do. I want you to pause me, go over this. You have the solubility rules. Decide if each one are going to dissolve or not dissolve. What's going to happen in water. Okay? Now that you unpause me, let's do this. H2SO3. First of all, you go, hold on a second. H2SO3 is an acid. So now the rules are different. I can use the solubility rules. Now, first of all, can you name this acid? H2SO3 is sulfurous acid. Okay. Weak acid or strong acid? This is a weak acid. Again, I will give this to you. Look over here. I'm going to come over here. These are the strong acid. H2SO4 is a strong acid, but H2SO3 is not on that list. It's a weak acid. Now, let's go over this one more time because I know it's a little crazy. All acids are soluble in water, but weak acid, not much would break up in water. Strong acid, they all would break up in water. So this is a weak acid, right? So if you have a weak acid, I want you to keep it together. I want you to keep it together because only a few would break up in water. So we're just not going to worry about it. You see a weak acid, you keep it together. Okay, because you know they would not break up into ions much. But I'm going to give it an AQ because all acids are soluble in water. Acid basically exists in water. So far so good. Beautiful. Next one. AuBr3. This is a tricky one. What do you think? AuBr3. Is that going to dissolve in water or not dissolve in water? So, I don't have a rule for Au, but I have a rule for halogen, which is Br, right? So let's go over this. Chloride, bromides, and iodides are soluble, except if they are next to copper 1, silver 1, gold 1, mercury 1, and Pb plus 2. What do you think? Most people are tempted to see, oh, bromide is next to gold, so it's not going to be soluble, right? Because remember, what we said is that if it's next to one of these, it's going to make it to be insoluble, right? Except there's a tricky part, and this is as hard as it could get. So I'm giving you the hard questions now. What kind of gold is this? Remember, transition mineral can have many different charges. So I know Br is -1. The 3 came from gold. So this is gold 3. You following me so far? Let's come back over here. I'm going to read this for you again. Chloride, bromides, and iodides are soluble except if you're next to copper 1, silver 1, gold 1, mercury 1, Pb plus 2. Oh, damn. The charge matters. Oh, this is so tricky. The charge matters, okay? So this one is gold 3 and not gold 1. So what that means is this one will actually dissolve. Which one? This one will actually dissolve. So when it dissolves into ions, it dissolves. I'm going to have a gold and I'm going to have 3 Br minus. this would actually dissolve. This would actually dissolve. And again, when you dissolve in water, you can have AQ. I usually forget to write them. You guys got that? I'm going to go over this one more time. Just I'm going to make sure you really get this down. So when you look over here is gold, right? Here is gold. And you go, oh, so if it's next to one of this, it has to be insoluble, except it has to be gold 1, and this one is gold 3. So this one would actually be soluble. Ready for the next one? Okay. Calcium hydroxide in water. What do you think? Would dissolve or not dissolve? So, there is no rule for calcium, but there's rule for hydroxide. Hydroxide are insoluble except if it's next to 1A, barium, strontium, and Ra. So, what do you think? So here, calcium OH is next to calcium. So it says hydroxide are insoluble. But if it's next to one of this, that would make it to be soluble. If it's next to one of this, that would make it to be soluble. So this part of the chart is the opposite of the top part, right? The top part, they're soluble. Next to this, it would make it insoluble. Now here, these are insoluble. Next to these guys, they're soluble. So hydroxide is insoluble. If it's next to 1A, BA, SR, and RA, it makes it to be soluble. Well, it's not next to any of those. It's next to calcium. So this would not dissolve. This would be insoluble. It would not dissolve. It would not dissolve. So what I would end up having, I would just have calcium hydroxide solid. You guys are good? Okay, beautiful. So it would just be solid. Let me give you one more practice problem. I know I said this is it, but just one more and then we move on from this. Okay, are you ready? So, H2SO4. What would that happen in water? Okay, if you look at this, the first thing you're going to say, whoa, H2SO4 starts with H. That means it's an acid. If I have an acid, I'm going to come over here. I'm going to look at my strong acid. Is H2SO4 a strong acid or weak acid? Oh, H2SO4 is on the list. So if H2SO4 is on the list, that means H2SO4 is actually a strong acid. Now, if it was a weak acid, I would just keep it together. Because the weak acid, not much breaks up. But the strong acid, they would all break up. So I'm going to break this up. When I break this up, I have H plus and SO4 minus 2. But how many H plus do I have? I have 2 H plus. Again, if you're having a hard time to kind of see what they break up into, this is the way to look at it. That H2SO4 is an ionic compound, right? SO4 has a minus 2 charge. And you have 2 hydrogens that are attached to it, right? Because H2SO4 came from, this is plus, this is minus 2, cross-multiplying charges. Now, when you break up, when you add it to water, water is going to break this up. It's going to have 100% dissociation. When this dissociates, when it breaks up, I have 1 SO4, right? I have 1 SO4 minus 2. And then how many H plus do I have? I have 2 of them. So I put a coefficient. I have 2 H plus. And that's where those things come from. You guys are good? Okay, so strong, and it's a strong acid, breaks up in water. I'm going to put AQ because AQ means dissolved in water. Okay, so let me write down the AQ again. What does AQ mean? AQ means dissolved in water. If something is dissolved in water, I'm going to put it AQ. Now, just remember, all acids are going to get AQ because even if the weak one that don't completely break up, they're still going to be soluble in water. All the acids are soluble in water. Sounds good? Okay. Now, this will be given to you again, of course. So you have this in front of you as you're deciding if something is going to dissolve or not dissolve in water. And if you have base or ionic compound, When they dissolve, they're also going to break up into ions, right? When they dissolve, they're also going to break up into ions. They break up into ions. But the acids, all acids are soluble, weak, not much breaks up, strong, they will all break up. Alright, so have this in front of you as you're doing practice problem. Nice job, nice job.